have a dream that one day
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
Welcome to the fifth lesson on arithmetic sequences and series. In this lesson, we want to look at sigma notation. There are three standard techniques that we want to discuss. The first one is writing series in sigma notation. The second one, evaluating a sum using sigma notation. And the third one is finding the number of terms when we are given sigma notation. In example 5.8 it says, write each of the following arithmetic series in sigma notation. Let's look at the first one. So we have the series 9 plus 5 plus 1 plus up to n terms, and we need to write this in sigma notation. We can start by writing down A and D. A is the first term, which is 9. D is the common difference, which is 5 minus 9, in other words, negative 4. Now we use the formula for T sub n, but we replace n with k. So T sub k equals A plus k minus 1 times D. And we're substituting A, so 9 plus k minus 1. And we also substitute in D, which is negative 4. Now we simplify. And we see that T sub k, the general term basically, is 13 minus 4k. So when we write something in sigma notation, we always find the general term, T sub k. Now we can answer the question. So the series 9 plus 5 plus 1 plus etc. up to n terms equals the sum of the general term 13 minus 4k, where k always goes from 1 to n, because we were told that there were n terms in the series. In the second series, we are not given the number of terms. We are given the last term though. So we first have to work out the number of terms. But let's start with what we have and what we need to find. We have A, it's negative 3. The common difference D we can get by taking term 2 less term 1, and we see this is 5. We don't have the number of terms, but we are given the last term, or the nth term. It's 142. Now we first use the formula T sub n equals A plus n minus 1 times D to find n. So let's substitute in. So T sub n is 142. A is negative 3, and D is 5. We can bring the negative 3 to the left-hand side, so 5 into n minus 1 will equal 145. So n minus 1 is 145 divided by 5. So 145 divided by 5 will give us 29, and then n will equal 30. So now we have the number of terms. We still have to set up the sigma notation, so we need the general term T sub k equals A plus k minus 1 times D, and we can substitute in the values of A and D. We saw that A was equal to -3 and D was 5. So -3 plus k minus 1 times 5. We simplify, and we see that T sub k, the general term, is 5k minus 8. Now we can write down the sigma notation. It was -3 plus 2 plus 7 plus all the way up to 142. So this then will equal the sum, once again, of the general term in terms of k, and k goes from 1 to 30, because we saw that we had 30 terms in the series. So in this question it says, write each of the following arithmetic series in sigma notation. And in the first one, we have 7 plus 4 plus 1, all the way up to n terms. We're going to start by writing down the values of A and D. A is the first term, and that's 7. D, the common difference, we can get by taking term 2 less term 1. So D is -3. Now we use the formula for the general term. T sub k is A plus k minus 1 times D. And we can find the general term. So T sub k is A, which is 7, plus k minus 1 times D, which is -3. We can simplify this equation. So it's 7 minus 3k plus 3, and this is 10 minus 3k. Now we can write the series in sigma notation. Of course, we had 7 plus 4 plus 1 all the way up to n terms. So hence 7 plus 4 plus 1 up to n terms will equal the sum of my general term, 10 minus 3k, where k goes from 1 to n. In the second part of this question, we are not given the number of terms, but we are given the last term. So we first have to write down, or find rather, the number of terms. So let's start with writing down what we have and what we need to find. A is the first term, and that's 5. D is the common difference. It's 9 minus 5, which is 4. We don't have the number of terms, but we do have the last term, or the nth term. That's equal to 85. So we can use the formula T sub n equals A plus n minus 1 times D to first get the number of terms. So let's substitute in. So 85 equals A plus n minus 1 times D. So we see that 4 into n minus 1 equals 85 minus 5, which is 80. So n minus 1 is 20, and n is equal to 21. Now, in order to write the series in sigma notation, we now need the general term T sub k, which is A plus k minus 1 times D. And we saw that A was equal to 5 and D was equal to 4. So A is 5 and D is 4. So this is 5 plus 4k minus 4, which is 4k plus 1. So now that we have the general term, we can easily write down the sigma notation. So it's a sum where k goes from 1 to 21. We saw that we had 21 terms of the general term. In example 5b, we are given the sigma notation and we need to evaluate it. In other words, we need to find the sum represented by the sigma notation. So we know that what's in front of the sigma notation sign, or in front of sigma, is always going to be the general term. So in this case, it's written in terms of n. So we know that T sub n will equal 2 plus 3 into n plus 1. Now, when we are given the sigma notation and we have to find the sum, we always start by writing down the first 3 terms. So T sub 1, or term 1, is 2 plus 3 into 1 plus 1. So this is equal to 8. Then the second term is 2 plus 3 into 2 plus 1. This is 11. And the third term, T sub 3, is 2 plus 3 into 3 plus 1. And this is equal to 15. From this, we can now see the values of A and D. A is the first term, and that's 8. D is the common difference, so we can take term 2 less term 1, and we see that D is 3. So now that we have the values of A and D, by the way, we also know that n is 15. The number of terms is 15. So now that we have the values of A, n, and D, we simply use a sum formula to find the sum. So S sub n equals n over 2 into 2a plus n minus 1 times d. And we want S sub 15. We have 15 terms. So plugging in 15 for n, we know that A is 8. 15 minus 1 is 14. And we also know that D is 3. This we can evaluate on a calculator. And we see that it comes to 435. So 435. So then the sigma notation here is a sum to 15 terms, and it comes to 435. Let's look at your answer to this question. We start by writing down the first three terms because we know that t sub k, the general term, is 36 minus 3k. So we can find term 1, the first term, by letting k equal to 1. So 36 minus 3 times 1, which is 33. Then the second term is 36 minus 3 times 2, which is 30. And the third term is 36 minus 3 times 3, which is 27. From this, we can see that the first term a is 33. The common difference d we can get by taking term 2 minus term 1, and that's negative 3. And we also know n, the number of terms, it's 62. Now we can use a sum formula and evaluate. So S sub n is n over 2 into 2a plus n minus 1 times d. And we want S sub 62. So just plugging into this equation, we saw that a was 33. 62 minus 1 is 61. And d was negative 3. Just using a calculator here, and it comes to negative 3,627. In this example, we are given the value of the sigma notation, and we have to find the value of n, the number of terms. So once again, we start by writing down the values of the first three terms. Since we know that t sub k, the general term, equals 5k minus 4. So then finding the first three terms, t1 is 5 times 1 minus 4, which is 1. And t2 is 5 times 2 minus 4, which is 6. Term 3 is 5 times 3 minus 4, and this is 11. So from this we can see that a, the first term, is 1. The common difference d is term 2 less term 1, so it's 5. And we also know that the sum to n terms is 55. So S sub n is 55, and we must find the value of n. So we're going to use the sum formula. S sub n is n over 2 into 2a plus n minus 1 times d. We can plug in our values. 55 is n over 2 into 2a plus n minus 1 times d. And we need to solve for n in this equation. We can start by getting rid of the fraction here. We multiply both sides by 2. So 110 equals n. The 2's cancel here, into 2 plus 5n minus 5. We can simplify inside the square brackets. And we can multiply out. Now we're going to end up with a quadratic equation in n. So 5n squared minus 3n minus 110 is equal to 0. And we can use a quadratic formula so we have negative b, which is 3, plus or minus the square root of b squared, which is negative 3 squared, minus 4ac, all over 2a. Let's evaluate first under the square root. So let's see what it comes to. And it's 2,209 under the square root. This is all over 10. Now, we can ignore the negative because n must be a natural number or a positive integer. It's a number of terms. So then n will equal 3 plus the square root of 2,209 all over 10. And then divided by 10, we see that n comes to 5. So the number of terms then equals 5. Let's look at your answer to the first question here. We are given this sum equal to negative 125, and we must find the value of n. We can start by writing down the general term. We know that the general term t sub k is 4 minus 3k. Now we can find the values of the first three terms. So then term 1 is 4 minus 3 times 1, which is 1. Term 2 is 4 minus 3 times 2, and this is negative 2. And term 3 is 4 minus 3 times 2, or rather 3. And this is 4 minus 9, which is negative 5. From this, we can see the values of a and d. A is the first term, and that's 1. D is the common difference, and we can take term 2 less term 1. We are also given the sum to n terms. It's negative 125. So S sub n is negative 125. And we need to find the value of n. So we use a sum formula. So S sub n is n over 2 into 2a plus n minus 1 times d. S sub n is negative 125. We don't know the value of n. A, of course, is 1, so 2 times 1. And d is negative 3. We can simplify the right-hand side. We can actually first get rid of the fraction here by multiplying through by 2. On the right-hand side, the 2's cancel. And simplifying inside the brackets, we get 5 minus 3n. We multiply the n into the brackets. And now we can bring everything to the left-hand side. So 3n squared minus 5n minus 250 equals 0. We now have a quadratic equation in n which we need to solve, and we're going to use a quadratic formula to do this. So then n will equal minus b. So minus b is 5 plus or minus the square root of b squared minus 4ac, and this is all over 2a, so over 2 times 3. We can first simplify under the square root. So negative 5 squared minus 4 times 3 times negative 250. It's 3025. And this is all over 6, of course. So all over 6. Once again, we can discard the negative sign because n is the number of terms and must be a natural number. So 5 plus, and we can get the square root of 3025. It's 55. This is all divided by 6. So it's 60 divided by 6, which is 10. In the second part of this question, it says, determine the largest value of n such that this sum is less than 200. In this case, the general term is written in terms of I. It doesn't really matter what letter we use, but we could write it down as t sub I or t sub k. In this case, it's t sub I equals 3i minus 2. If we use k here, then we have to write the right-hand side as 3k minus 2. So now we can get the first 3 terms as usual. So term 1 is 3 times 1 minus 2, which is 1. Term 2 is 3 times 2 minus 2, which is 4. And term 3 is 3 times 3 minus 2, which is 7. So now we can see that the value of A is 1, and the value of D, the common difference, is 4 minus 1, which is 3. We need to find n, but we also know that S sub n, the sum to n terms, must be less than 200. So using the sum formula, S sub n we have n over 2 into 2a plus n minus 1 times d. D is 3. This must be less than 200. Less than 200. And we can multiply both sides by 2 to get rid of the fraction here. At the same time, we can simplify inside the brackets. Multiplying the right-hand side also by 2, we get 400. And in simplifying inside the square brackets, we can multiply the n into the square brackets. And we can bring the 400 to the left-hand side. And we get a quadratic inequality, which we need to solve. And once again, we can use the quadratic formula for this. We can first solve this as an equation using the quadratic formula. So n is negative b. B, of course, is negative 1. So it's negative b, which will be minus negative 1, which is 1, plus or minus the square root of b squared, minus 4ac. This is all over 2a. And we can first work out under the square root what it comes to. And it's 4,801 under the square root. This, of course, is all over 6. So all divided by 6. Once again, we can discard the negative. So n will be 1 plus, and we can work out the square root of 4801. And it's 69.29 rounded off to 2 decimal places. But we're going to keep all the decimals because you want to round off only the final answer. So 69.289, etc. All divided by 6. So then adding 1 to this answer and then dividing by 6. So n is 11.71. Now remember that we needed to solve this quadratic inequality, this being less than 0. So this means that n is less than 11.71. The number or the natural number just below 11.71, of course, is 11. So this means that n is 11. So we've answered the question. It was determine the largest value of n such that this sum is less than 200. So the largest value of n for which a sum is less than 200 is n equals 11. Let's look at the answer to the first question here. We are given the sum in sigma notation and it comes to negative 4. We must find the value of n. So we can start with a general term. In this case, it's written in terms of r. So t sub r will equal 4 minus r over 2. Now we can find the first 3 terms. So term 1 is 4 minus 1 over 2, which is 3,5. Term 2 is 4 minus 2 over 2, which is 3. And term 3 is 4 minus 3 over 2, which is 2,5. From this, we can see the values of a and d. A is the first term, that's 3,5. And d is the common difference. We can take term 2 less term 1. 3 minus 3.5 is minus a half. We are also given the value of s sub n in the question. It's negative 4. So s sub n is negative 4, and we need to find n. And of course, we're going to use the sum formula. So plugging in our values, S sub n is so then n will equal, using the quadratic formula, negative b, so 7, 5, plus or minus the square root of b squared minus 4 minus 4ac. And this is all over 2a. So 2 times 0,5. So plus or minus. We can first work under the square root again. So let's see what that comes to. And that's 72,25. So 72,25. 2 times a half, of course, is 1. So it's all over 1. Once again, we can drop the negative. So n will be 7,5 plus the square root of 72,25. All over 1. Now, just to work this out on a calculator, 7,5 plus the square root of 72,25. And it comes to 16. So n is equal to 16, the number of terms. In the second question here, we are given the sum in sigma notation, and we are told that it comes to 1,272. In A, we have to write down the kth term of the series. That's quite easy to do because we know that what's written in front of the sigma notation is a general sum. So we just take this expression and replace P with K. So T sub K, this of course is A. So T sub K will be 2 into 2K plus 1 plus 1. In B, it says one of the terms is 63. Which one is it? So let's look at B. We have the general term. So we just take the general term, 2 into 2K plus 1, and we make it equal to 63. And we solve for K. We can multiply in here. So it's 4K plus 2 equals 63 minus 1, 62. We can take the 2 to the right-hand side, and 4K is 60. And then solving for K is 60 divided by 4. which is 15. So the 15th term will equal 63. Let's look at C. We have to write on the sum of the first 24 terms. Now, P goes from 1 to 24. So this is already the sum of the first 24 terms. So 1272. Let's look at the answer to the fourth question here. We are given these three terms. It's the first three terms of an AP, so negative 1, 2, and 5. And in A, we have to find the nth term, T sub n, of the sequence. This is just another way of asking us to write down the general term. And we have to write it in terms of n and not k in this case. So our sequence is negative 1, 2, and 5. And from this we can see that A, the first term, is negative 1. And the common difference D we can get by taking term 2 less term 1. And we can see that it's equal to 3. Now we use the formula T sub n equals A plus n minus 1 times D. And we merely replace A and D with numerical values. We can simplify. And T sub n then is 3n minus 4. In the second question, we have to calculate T sub 43. So the value of the 43rd term, T sub 43, we plug in 43 for n in the general term. So 3 times 43 less 4. And we see that it comes to 125. In C, we have to calculate the sum written in sigma notation. And it's a sigma, or the sum, of T sub k, where k goes from 1 to n. We know that this is just the sum to n terms. So we really want the general sum in C. So we can say that the sum of T sub k, where k goes from 1 to n. Now, remember that it's always a general term that's written in here in front of the sigma. This is just the sum to n terms of the sequence. So it's n over 2 into 2a. And we saw that a was negative 1. And d was 3. So it's going to be n over 2 into negative 2 plus 3n minus 3. And it's n over 2 into 3n minus 5. And we can simplify this by multiplying into the brackets. And it's going to be 3 over 2 n squared minus 5 over 2 n. So this is the general sum then of the sequence. In number 5, we are given this sum to n terms. And in A, we have to find the general term of the series in this form. T sub k equals bk plus c. Once again, we just want the general term. In order to do that, or to find the general term, we just need A and D. So we can see that A, the first term, is negative 3. D, the common difference, is 5 minus negative 3, which is 8. And now we can find T sub k. It's going to be A plus k minus 1 times D. And we plug in the values of A and D. So negative 3 plus k minus 1 times D. We just simplify and add like terms. So T sub k is 8k minus 11. In number 2, we have to write the sum in sigma notation. That's easy because we do have the general term. So then S sub n in sigma notation will be the sum where k goes from 1 to n of the general term. In other words, of 8k minus 11. In C, we have to show that S sub n equals 4n squared minus 7n. This is just another way of asking us to show that the general sum comes to this. So we can use a sum formula. So we know that S sub n is n over 2 into 2a, and we do have a. A is negative 3 plus n minus 1 times d, and we saw that d was equal to 8. So whenever we find the general sum, we use the sum formula and just replace a and d with numerical values. So that's n over 2 into negative 6 plus 8n minus 8, which is n over 2 into 8n minus 14, and multiplying into the square brackets n over 2, we get 4n squared minus 7n. And this is what we needed to show or to prove, that S sub n is 4n squared minus 7n. Let's look at number 6 here. We are given the sigma notation, or the sum, and we are told that it's equal to 36. What's important to note here is that b is in the place of n, the number of terms. So when it says determine b, we actually have to find the number of terms. A second thing to note is that we don't have brackets around 5a plus 2. However, the sum here, the sigma notation, applies to both 5a and 2. Because if we don't apply sigma notation to 2 and just to the 5a, we'll find that the number of terms is not a natural number. So it's conventional often not to write brackets around what's in front of the sigma notation, even though the sigma notation applies to everything in front of it. So we proceed as usual. We find the first 3 terms. So term 1 we get by plugging in 1 for a. So term 1 is 7. Term 2 we plug in 2 for a, and it comes to 12. Term 3, plug in 3 for a, and we see it comes to 17. So from this, we can see that the first term a is 7. The common difference d is 12 minus 7, which is 5. the sum to n terms is 36, and we have to find n, which is in this case b. So we can use a sum formula, and instead of writing s sub n, I'm now going to write s sub b, which is b over 2, into 2a plus b minus 1 times d. Then plugging in, s sub b is 36, that's b over 2 into 2 times 7, plus b minus 1 times 5. So b is a number of terms in this case. We get rid of the fraction here by multiplying both sides by 2. So it's going to be 72. We just simplify inside the square brackets. So 14 minus 5 is 9. And this turns out to be 5b squared plus 9b. We can bring everything to one side. So we have a quadratic equation in b, which we need to solve. And we're going to use the quadratic formula. So b equals negative b in terms of the quadratic formula. Of course, b in the formula ax squared plus bx plus c equals 0. b in this case is 9. So it's going to be minus 9 plus or minus the square root of 9 squared minus 4ac all over 2a. And we can work out under the square root first. So let's use a calculator. So 81, just finding the value under the square root. And it's 1521. This is all over 10. B is a number of terms, so we can discard the negative. B has to be a natural number. And finding this on the calculator, we have negative 9 plus the square root of 1521 divided by 10. And we see that b is equal to 3. In number 7, we are given the series 1 times 2 plus 5 times 6 plus 9 times 10, etc., all the way up to plus 81 times 82. And we have to write the series in sigma notation. We are also told not to calculate the value of the series. This looks like a tricky question, but if we look more closely, we have a number of terms, the terms being 1 times 2, then 5 times 6, then 9 times 10, etc. And in each of these terms, the first set of factors, in other words 1, 5, 9, 13, etc., forms an AP, and so does the second set of factors, in other words 2, 6, 10, 14, etc. Now, we are multiplying the factors in each case. So our strategy will be to find the general term of both the first and second set of factors and to multiply the general terms under the sigma notation. So let's look at the first set of factors. It's 1, 5, 9, 13, all the way up to 81. We've got the first term A, which is 1. Of course, we want to find the general term of this AP. So A is 1, D is 4. The value of the last term, or the nth term, is 81. And we don't know the number of terms. So we can use the formula T sub k equals A plus k minus 1 times D. And A is 1. D, of course, is 4. And we can simplify this. And we find the general term for the first set of factors is 4k minus 3. Now we can look at the second set of factors. It's 2, 6, 10, 14, all the way up to 82. So let's write it down. 2, 6, 10, 14, up to 82. In this case, A is equal to 2. The common difference D is 4. We don't know the number of terms, but we do know that the value of the nth term is 82. Once again, finding the general term, A is 2, and D, of course, is 4. So then, just simplifying this, we see that the general term for the second AP, or second set of factors, is 4k minus 2. We're almost ready to write the sum in sigma notation, but we do know we do need the number of terms. So we're going to use the formula T sub n equals A plus n minus 1d. Or rather, we could use this formula and plug in 82 for T sub n and 2 for A, etc. But since we already have the general term, we can either use the general term of the first set of factors or that of the second set of factors in order to find the number of terms. So let's use the second set of factors. We're going to use the formula T sub k is 4k minus 2 and use 81 for T sub k, or rather 82. So it's 4k minus 2. And in solving for k, we see that it's equal to 21. So now we can write down our final answer. We needed the sum of the series. So it's sigma, or the sum, where k goes from 1 to 21. And we're going to multiply the general terms. So it's 4k minus 3 multiplied by 4k minus 2. And this is our answer to the question.